Hi, everyone. Thank you so much for being here today. I hope you're enjoying WIDS thus far and you're having a fun time with these workshops. Today, I'll be taking you through a workshop that scratches the surface of design thinking for data science problems. I think a lot about this area, and by combining the expertise in these two areas, I think there's a huge potential to tackle even bigger challenges that in the world that we're facing today. So first, I'd like to welcome you all. My name is Sita. I am a PhD candidate at Stanford University in mechanical engineering and human-centered design. And I'm delighted to be here today with you all. So I'm excited to have some fun with you for the next 40 minutes or so. I have two goals for this workshop. One is I'd like you all to learn the different stages of the design thinking process and how data science project steps might apply to each stage. Second, I'd like to do an activity to practice the reframing mindset that you'll soon understand what that means. Heads up for what you'll need for this workshop, so you can grab it now. You'll need a pen or a pencil. You'll need a few sheets of paper. And I'm asking that you'll bring your creativity. Throughout this workshop, I'll be asking you to look at problems in a different way than you may be used to. So I'm asking for your willingness to learn and your open-mindedness. This perfectly segues into the start of our first part. Our friend Marcel Proust, the French novelist, described our journey perfectly. He said that the only real voyage of discovery consists not in seeking new landscapes, but in having new eyes. I hope that this workshop will help you see a familiar landscape of data science problems with new eyes. Let's start off with a mini activity. Hopefully, this is a familiar topic to you all. Let's say that you had to define and solve a data science related problem with a team. So this is a very broad prompt, and I am asking you all to think about what steps might you take. So grab that pen or pencil, grab one of those sheets of papers, and I'm going to give you about 60 seconds. So I want you to think about, take some notes, make some drawings on what are the steps you might take to actually go through and define and solve a data science problem with a team. Okay, so about 60 seconds. Okay, so hopefully you have a couple of things on your page of paper. So I naturally, to understand this problem, I'm a designer. I thought I would go do some interviews. I wanted to interview my data science friends, students in data science programs here at Stanford, in engineering and computational math and statistics and the like, to get their view on what these steps might look like. Here's what they looked like. Their answers, you always started off with the data and then used that data to define the problem. Then data cleaning and model selection were usually in the mix, which then usually led us to solving the problem. However, I also heard this very interesting theme over and over again that I wanted to share, really embodied in this quote from one of my interviewees. This person said, "First I panic, then defining the problems is the hardest part. I get nervous." People said that the hardest part is defining the problems, especially in the field of data science. We're dealing with some of the toughest, most complicated challenges. Solving these problems is hard, but defining these difficult and ambiguous problems is even harder. Defining problems without care or intentionality can lead to biased problem solving and solutions that could potentially hurt others or have unintended consequences. This is where the design thinking process comes in. Generally, we focus on problem solving in data science, especially because we're usually trying to come up with some sort of strategy or outcome or business value. We have an obligation to our company, our research advisor, our client, or whatever. I want to probe at where do these problems actually come from? In design thinking, we put as much emphasis, if not more emphasis, on the problem finding as much as we do the problem solving. The thought is if we put more initial effort into the upfront steps to define a meaningful, robust, human-centered problem that's relevant in the context we're working in, then the rest of the steps will follow through and will have an even greater impact if we compared to if we just solved a problem that we found from the data. So instead of this problem-solving skeleton, I propose something that perhaps looks more like this. A problem definition process that starts with real people and their needs, and then has these very important steps of our data science problem solving process that we're familiar with, but all with the openness and the willingness to go back to the original problem, reframe to those contextual clues and the things that we got from the people that we talked to. This is often difficult for data scientists, especially those who are new to the field, because as we know in data science education, we're generally taught to start with the data and then try to create a problem based on what we see from the data, instead of starting with people and the context and then figuring out what would be the most meaningful problem to focus on. I propose that this process actually leads to better data science, better problem solving, and better solutions for the world. I've been saying and throwing around the term data science and design thinking quite a lot. Let's talk about what the heck design thinking is anyways. So in a nice little sentence definition, it is the nonlinear, iterative, human-centered approach for creative problem solving. I'd like to take you through some pictorial representations and give you a brief overview of how this process works and how it relates to different considerations in data science. We're going to take a deeper dive into this first model, the 5 hexagons model. It's probably the most famous rendition of the design thinking process that you'll see. It comes from the Stanford Hasso-Plattner Institute of Design, and this institute is more famously known as the D School. I'd also like to add one more step to this 5 hexagons, and that is to iterate. This process does not work linearly, and it can only work if you're willing to iterate within each step and in between each step in the overall process. Let's go through each step one by one to better understand how the process works and how that relates to our data science frameworks. The first step in design thinking is empathy. The magic sauce this process brings is that people are front and center of the approach. Understanding the stakeholders involved and their needs and their drivers is typically not accounted for in data science. However, this is where the true understanding of the essence of meaningful problems begins, with people, how they live their lives, what are their pain points. For instance, perhaps you want to gather survey data for a project and you want to gather a lot of it. However, without reflecting and understanding the people that are taking your survey answers might not reflect what you want to show and therefore give a biased data set. Or perhaps you're working on a recommendation system for a vaccine company to suggest where they should be distributing vaccines. This is a pretty relevant problem in today's age. You can't build an appropriate tool if you don't understand the nuances of who is being involved in the distribution, who's using these recommendations and who's making the decisions, and who's being included in distributions. Issues of equity and ethics come up often when we put humans at the forefront of our analyses. And don't let the qualitative nature of this step fool you. Empathizing with stakeholders is a large endeavor. It takes time, training, and intentionality. However, if done right, the input to your eventual problem and the solution add a deep layer of richness and meaningfulness that you just simply can't get by only starting with the data. The second step is about defining the problem. As we talked about, this is the hardest part of the whole process. Building upon your work from the empathy step, key insights often emerge as interesting points and insights, contradictions from the problem context, or even surprises that you didn't even realize existed. This step is an intentional time for you and potentially your team, if you're working on one, to synthesize what you've learned and consider perhaps what data is available without any analysis yet, but to be able to define a clear problem statement that is relevant. This clear statement defines how you and your team are looking at the problem, what the stakeholders are that you're considering, and how you want to move forward with your analyses. Suppose you're creating a resume hiring system. Silicon Valley knows a thing or two about that. Consider what would it have been like to design that hiring algorithm if you spoke to potential employees who would be submitting their resumes there, the recruiters who would use that information and make decisions, and other people involved in the hiring process. Understanding these different points of view and synthesizing that information may have led to a very different problem and a very different outcome, one that did not discriminate certain types of people and or resumes. Once you have this clear problem statement, the third part of the process is to ideate. Now that we have this problem defined, it's time to figure out what types of solutions might be possible. Here's where the data comes in. We need to understand what data that we have that could solve our clearly defined problem, not use the data to define the problem for us. This may also include the different types of models available and how to select which to use. You get the idea. The point is, the data and the models are tools on how we solve the problem, not the problem drivers. And the ideation step helps us search the space of possible solutions. We want and really need this time for open idea generation without judgment, and using techniques like brainstorming to explore the whole space of possibilities, and then be able to narrow down our ideas to the few that we want to try, which naturally leads us into the prototyping stage. This is the stage where our down-selected ideas from the ideation stage can really come to life and get tested. Prototyping is not about perfection. In fact, it's quite the opposite. It's about low fidelity ways to test your concept. This may look like a drawing to show your user to figure out what kind of outputs you want your model to give. It could be an approach that the user experience or user interaction experts use, like wireframes. You may also think about prototyping different types of code to see what works and what doesn't. Maybe you have different visualizations that you're prototyping. So naturally, then, once you have these prototypes, the final step you'd want to do is to test these prototypes. This is where the important feedback comes in. Since you've already started with your empathy stage and you've heard about who that solution is serving, what stakeholders are involved, and who might be affected by the solution, you can go back to these people and ask them what they think. Let's say, continuing with our vaccine distribution example, that your model that you built gives important outputs and you think that they're important. And then when you put those in front of your original stakeholder, let's say a public health official who's going to make decisions based on this recommendation, they actually tell you that they don't need X, Y, Z, but they need A, B, C outputs. You would never know that until you test it. So once you have these prototypes that then you test, that's all part of the iteration step. So you want to be iterating all along, and at the end, really trying to understand, is the final result that you have really serving the people that you worked with at the beginning of the process? Now, this whole process takes practice. loads of practice. But the results after using the steps may just be better, more meaningful, more contextual. You can look for biases and watch out for unintended consequences in your work. That's what's happened when I've used this process in my own data science work. Now that we've taken a deep dive into this particular model, let me show you some other visualizations of this process that may provide you insight. I want to show you this framework of the 8 design abilities. This is a framework that the Stanford D School is actually moving towards in addition and enhancing the 5 hexagon models. So these 8 design abilities are the abilities that are necessary for designers to do good work. And I think that these apply to all the data science examples that we just went through. This includes navigating ambiguity, learning from others, synthesizing information, experiment rapidly, move between concrete and abstract, build and craft intentionally, communicate deliberately, and design your design work. You can see how many of these themes popped up in the examples we talked about with the 5 hexagons model. IDEO, a famous design company in this area, also uses this framework. They say that design thinking and true innovation leads us to this intersection of feasibility, desirability, and viability. So that intersection of those 3 areas are what give us true innovation. This is really helpful from a business context and may be useful for you thinking about in your own companies, how you're doing your work and how that relates to the business context of your company. Last, but certainly not least, my favorite rendition of the data science, of the design thinking process is this. We start off swimming in tons of uncertainty, and slowly by slowly, little by little, we get to the ending point of clarity. Now, the trick with all of this is actually getting comfortable with this part, which, as I'm sure you can all relate, is not easy at all when we're swimming in uncertainty. And so exactly that idea is what I want to now segue into the second part of our workshop. Let's do an exercise to get comfortable with that uncertainty. So I'd like everyone to take out their pen or pencil and a piece of paper. And what I need you to do is draw 30 circles on that piece of paper. So I've got some paper here. I'm going to do it with you. So let's see. Got 5 across. Doesn't have to be perfect. Let's do, okay, 5 across, 6 down. Okay. Do you have your 30 circles? Do you have your pen or pencil ready? So what I'm going to ask everyone to do is I want you to turn as many of these blank circles as possible into recognizable objects. And you have 3 minutes to do that, okay? These directions are intentionally vague, so go with it. You have 3 minutes. On your mark, get set, go. How are you doing? Do you have all of the circles done? Keep going. Okay, pencils down. Pencils down, no more trying to fill in circles. All right, so how did that feel? If it was anything like what I felt the first time I did this, perhaps it was something like, ooh, maybe it was something like, oh dear. Or like what I felt when I first did this, that's what I felt. So a couple of questions to reflect on. Were you stuck? Were you thinking about all the different types of smiley faces or frowny faces or angry faces that you could do? And then you just couldn't think of any more faces to put in. What did that feel like when you were stuck? Then did you have an aha moment? You were doing all these faces and you said, oh, I know, balls. I can do balls. I can do a basketball and a baseball and a volleyball. And I don't know what other type of playing balls I can do. But that aha moment, that time when your brain said, oh, I got it. I unlocked this new thing. And then you went and you kept going and you kept going and maybe you got stuck again. So this tension between feeling stuck and getting unstuck, stuck and unstuck is really powerful. This experience that you just went through shows us that our brain groups solutions into schemas. So like I was saying before, and probably what you all did was you looked inside the circle. You put smiley face, frowny face, maybe angry face. You were stuck, and then you had this aha moment and you said, oh, I'm going to do a basketball. There's my really sad rendition of a basketball. And then baseball, and then this type of playing ball and this type, right? But, you know, who said that you had to keep the drawings inside the circle, right? Did anyone think about drawing something outside of the circle? Perhaps using multiple circles? How about using the circles for something 3D? Or perhaps you just chucked the rule book right out the window and you ripped it up, or you made a paper airplane and tried to throw it at me through the screen. You manipulated the paper in some way. So when I facilitate this when I have in the past in person, I often get the, you didn't tell me that that was allowed, or I didn't realize I could do that. The truth is, I didn't tell you any of those rules. All I said was to turn the circles into recognizable objects. That could have been any of these examples. It's our brain that groups these solutions into schemas, which then gives us rules that no one ever gave us except for ourselves. So now knowing this, let's try take two. Pull out a second piece of paper. Okay, I'm going to pull out a second piece of paper with you. And I'm going to have you draw the same shape, 30 circles again. Okay, so I want 5 across, and let's do 6 down, 3, 4. Okay, do you have your 30 circles? You're going to have the same direction. You're going to have the same amount of time, about 3 minutes, but I'm going to give you a new rule. I want you to build off of ideas that I gave you. It's as simple as that. On your mark, get set, go. All right, and stop. So let's talk about that. How did that round feel? I'm hoping it was something more like this. So this exercise, if you haven't already figured it out, is really about reframing the problem, taking away those rules that our brain puts on us, and accessing this whole new problem space that we didn't even know existed because of our own rules that we're making. So this 30 circles exercise was borrowed, and this content was borrowed from two of my professors, David Kelly and Bill Burnett. And this exercise is a lot of really great learnings that I hope you can take to your teams and the people that you work with. So first, it's really good at creating the getting stuck feeling. I think we all felt that with trying to fill those in the first time. It also helps us to think about and reflect, how does the unstuck feeling happen? When does that aha moment come? This is really relevant when we're thinking about a lot of our big, challenges and problems that we're trying to work on, right? And working through these problems, how are we getting stuck and unstuck and feeling super comfortable with the tension that those two areas cause? Our brain makes up boundary conditions, which affects our outcomes. This is huge, right? This is exactly the type of thing we don't want to happen when we're creating rules for ourselves, for problems, and for solutions that we then can't access the full solution space, right? We're doing our problems a disservice. And we also learn through this that solutions may exist that our brain won't even let us access, right? So what are we doing, and how are we pushing ourselves and our teams to really understand things about our problem and how we're defining the problem that either narrow or make larger? What are the different areas that we can access for potential solutions, right? We want to be able to access all those solutions, not let our own brain keep us from holding back, or keep us holding back. And then finally, this really demonstrates how people, teams, and companies end up in ruts. We all know what that feels like. So how are we going to get ourselves out of those ruts? How are we going to get unstuck and access this wider array of opportunity? This is a huge hit with many executives and C-suite executives and companies and all types of people, technical, non-technical. And I think that these lessons are really pertinent to people in the data science area. I know I've benefited a lot from this kind of mindset when approaching my problems. So I wanted to end with this part of the workshop with this is David Kelly, a professor, one of my professors at Stanford, a professor in Stanford design, and one of the founders of the D School and of IDEO. And he says that design thinking is all about unlocking potential and creating creative confidence. And so this is his idea, creative confidence, of having the confidence to allow ourselves to be creative, to allow ourselves to access those solutions that we might not normally want to because we've hidden behind, oh, I'm not a creative person. We are all creative people, and we should develop the confidence to let that shine in whatever work we're doing. So this is a really powerful mindset, I think, going into any sort of data science problem. And I encourage you to share this with your team. So we're coming to the end of our workshop. I want to relate this back first to the original problem-solving probe that I proposed to you all. Relating this back is really understanding this process and how each of these steps can really be taken intentionally and reframing back and really understanding the core of defining that problem meaningfully. I also would note that this also takes a little bit of trust, right? So there was a difference in the 30 circles when I told you vague instructions and I played Flight of the Bumblebee that induces a lot of nervous feelings, right? If the second time when I brought you along for the journey and I played some nice relaxing music, we were able to gain a little bit more trust and you felt more comfortable, I hope, right? So I would think about bringing this back to your teams and how you're leading your teams to be solving and going through this type of process, whether it's with qualitative data, numerical data, data cleaning, model selection, stakeholders' needs, whatever process you may be on. It takes trust. Now, like I said at the beginning of this workshop, oh my goodness, this is only the scratching the surface. So there are so many topics I wish I could dive into with you all, but I just wanted to list them here to get you thinking. You know, we have so much more to go into with stakeholder empathy, really how to understand what people are thinking and feeling and worrying about and driving, and really using that to understand and identify the needs that helps us drive what kind of problems we're defining. You know, this brings up a lot of really interesting problems also about data ethics and integrity, not only how you're getting your data, who you're sharing this data with, how these data are being used, where they're coming from, the relationship with the stakeholder. Lots of really interesting issues there and considerations. You know, so much to go into on techniques for problem definition and reframing, and how to actually go through these exercises of framing the problem that you think you have and you think it's good, and maybe you can even make it better. So then moving over to the second column, there's so much to talk about in equity and solutioning. What are the solutions we're coming up with? Who is it serving? How are these benefits and burdens being distributed? Huge implications there. I think techniques and ideation, as we just scratched the surface, there are so many to think about, and how can we defer judgment and really broaden the types of ideas that we're working with the people that we're brainstorming and ideating with. Lots to talk about there. I think storytelling is a critical piece of data science, right? How are we showing and communicating our results? How are we disseminating these results? Who are we disseminating them to? How are we showing them? Is this an output of code? Are we showing them in, you know, beautiful figures? What are the figures saying? How are we exploring the space that we're trying to show? How is the solution being, you know, given? We really need to tell a story about the process that we've went through to show the context that our work is in, not just what the work shows. And then finally, I would offer this idea as well to go into things like critiquing and feedback, right? We can only get better and we can only iterate if we have this culture of critiquing each other and providing constructive feedback, to check our biases, to make sure that the assertions and the assumptions that we're making are actually relevant or true or correct, or they work in the context. So using these kinds of techniques with our teams is really powerful also for gaining trust with each other and hopefully providing the most amazing solutions possible for these really hard challenges. So you might be thinking, oh, I want to learn more. Where do I go next? So I've compiled a couple of resources that I would suggest that you go to next. So if you want to learn more, I would definitely suggest going to the D School website. They have tons of free content that you can learn and engage with, and some activities you can use with your own teams. They also have fantastic executive education programs and boot camps and things like that. So take a look at their website. If you want to take some more class type opportunities, especially focusing design thinking in different areas, you may consider looking at IDEO. So the design firm IDEO has a IDEO University that has fantastic classes that you can take, ranging from self-paced all the way to a couple of months. So take a look at those opportunities there. If you want to go out and do something, you want to try some of these techniques out, I would suggest you start with Mural, which is this fantastic online collaborative whiteboard space where you can sign in. If you are an educational, if you're with an educational institution, you can get a free account, and you can collaborate on a whiteboard with Post-it notes and drawings and figures and everything. You know, in this age of the pandemic, especially, where we wish we could be in front of the same whiteboards, but we can't. So Mural is really a fantastic solution for collaboratively working visually on these types of problems. I've used it for basically every single one of my projects, so I highly recommend it. I also wanted to recommend digging deeper into this hiring algorithm example that we talked about. So if you haven't already heard of this fantastic game called Survival of the Best Fit, it's a game that you can go through to really understand how good intentions can actually lead to bad or biased outcomes. So I'd encourage you to play that game and then think about how the design thinking process could have helped change these outcomes or change the way that this algorithm was built. So really fun game, would highly recommend that. And then finally, we all love reading. Here's 3 books that I'd suggest you read to get started. So the first one is Creative Confidence, the book that I had mentioned from the quote from David Kelly. David and his brother Tom wrote this book, and it's a really, really great overview and starter of this design thinking mindset. I would also recommend Wired to Care by Dave Patnaik, who is an alum of the Stanford Design Program and also a current lecturer there. And he wrote this, his day job is not a lecturer at Stanford. He is the CEO of Jump Associates, a really fantastic design firm. And he wrote about how empathy really drives business results and better business. So from a business perspective, it's a really great book. And then finally, a book that I personally have really enjoyed called Designing Your Life by my professor, Bill Burnett, and his business partner, Dave Evans. And they wrote about applying the design thinking process and mindset to your own life, whether it's personal, professional, career, lots of really great ideas in there. It's very actionable, so I'd highly recommend you check it out. And so, the last parting words that I'll give you is from Ray Eames. So Ray and her husband, Charles Eames, were very influential designers in bringing design to the field it is today. And she says, choose your corner, pick away at it carefully, intensely, and to the best of your ability. And that way you might change the world. I have a feeling everyone at this conference is changing the world in their own special ways. And I am just so delighted to be able to have this time with you all. So thank you so very much for spending your time with me at this workshop and at WIDS. And I just really wish you all the best of luck. And hopefully you learned some takeaways from this workshop that you can take into your own world and make your data science work even better to help our society. So thank you again for your time, and I hope you enjoy the rest of the conference.